Okay, this is a video response to one of my LinkedIn group members on the Mathematical Card Magic LinkedIn group. Okay, their question dealt with Bessie sequences of order 32. Now, I do have a number of videos that I've created that talk about Bessie sequences of this longer length, 32. So I'll link those in the description below so that you can learn more about them. And more specifically, you'll learn, okay, how is it that this is a Bessie sequence of order 32? Okay. Now, for most people, this will just look like a random collection of card values, suits, and colors. And like I said, there's 32 of them. Okay. But what I told the subscriber is I would just give a very quick, simple example of something you could do with a Bessie sequence of order 32. Okay, so I'll go ahead and gather this. Now, I do want to point out that this sequence has all of the same properties and degrees of invariance that a Bessie sequence of order 8 has. Okay, so if you're familiar with those, you'll know that there are hundreds of unique ways of mixing a Bessie sequence of order 8 and not fundamentally hurting, harming, or changing that organization of the cards. The same is true here for a Bessie sequence of order 32. So we could really mix this in almost countless ways with important input from the spectator on how things are done, the order of things, the stacking of things, how many times we do things, and it will not in any way undermine what we hope to accomplish with this particular arrangement of the cards. Okay. Now, no other arrangement of the cards out there can be put through the same sequence of shuffles and mixing procedures and not be utterly destroyed. Okay, so what we'll do is I'll just do a little bit of mixing, okay? But just know we can deal out into 2 piles with random stacking from left to right, 4 piles with random stacking from left to right or right to left, or even leapfrog. We can deal out into 8 piles, same thing there, random stacking from left to right or right to left, or leapfrog. Into 16 piles, we can do an even and odd up jog. So this is an even up jog. So I'm jogging forward the even position cards. We can do Pharaoh shuffles. We can do Klondike shuffles. We can do Mons shuffles. We can do the Australian down under shuffle. We can do many, many mixing routines that people use today. Random stack here. Okay. Now, after any amount of mixing is done to the satisfaction of the spectator, all we're going to do at this point is deal out half the cards. So 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. And now we're going to do something that is recently presented on my channel. This is a fairly recent discovery. So if we rosette shuffle or riffle shuffle these 2 packets together, so rosette shuffle is this, it's mathematically equivalent to a riffle shuffle, and then you just bring these together however they choose to interlace. And then from there, what we're going to do, despite the fact that, we've mixed it before this rosette shuffle, and so just imagine mixing it in half a dozen other ways that we didn't perform here, but we could. And then we dealt out half of them, and then we did this very unpredictable, messy rosette shuffle. No one was controlling how those cards were interlacing. Okay, so we have no idea how they've interlaced. Okay, but despite all of that, we are going to be able to separate this packet of 32 cards into 2 piles of 16 cards, where within each pile of 16, we will have a perfect balance of red and black cards. And this is without us knowing anything about the color distribution of the packet. Okay, so to achieve that, we're going to perform a powerful shuffle called a Klondike Shuffle. So this is where you take the top and bottom card off as 1. And we're going to do it for 8 pairs, and 2 times 8 is 16. Okay, so here's the first pair. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so the claim is that we have been able to create two piles of 16 cards that are in perfect harmony within themselves, but also between the two piles, because each pile will consist of exactly 8 red and 8 black, even though we had no idea where any of the particular cards were in the packet that we've just now Klondike shuffled. Okay, so let's check to see if that's even true. So I'm claiming an equal number of red and black right here. So we have a 1 red, 1, 2, 3, 4, 5, 6, 7, 8, and the rest are black. What about over here? Ace 1, 2, 3, 4, 5, 6, 7, 8. We did it. Okay, so how in the world can something predictable and anticipated result from so many random choices being made by the spectator to thoroughly mix the cards? Okay, so that is the big punchline for these special packet structures. The fact that they're invariant relative to virtually all of the systematic mixing procedures anyone is using out there. Okay, that's the remarkable thing. Okay, now, and the fact is, once you have these with an equal number of reds and blacks, from here there's so many traditional card effects that you can break off into that require like a packet that has an equal number of red and black, a packet that has an equal number of red and black. And we have structures here that we can now take advantage of in more traditional card magic that has and is already being shared out there. So anyway, thank you for watching. I thought I would just answer this LinkedIn group member's question. And so here is a just very simple, surprising outcome and predictable outcome, regardless of the many random decisions made by the spectator regarding stacking order, number of piles to deal out, which shuffles to perform, how many of them, and what order, and so forth. Okay, and then this rosette shuffle, boy, that is just mind-blowing that we can bring those two packets together and still know something about the resulting structure. Okay, and then I also want to point out that the Gilbreth principle in no way is being used here. Even though towards the end it may have felt like, okay, we did a Gilbreth shuffle. Well, you might think the Gilbreth principle is being used here, but the problem is it can't be used because the Gilbreth principle requires cyclic packets before you perform the Gilbreth shuffle. And as you might imagine, a Bessie sequence of order 32 is not a cyclic construction at all. And then we do all of that mixing, and so if it were cyclic, it would have been destroyed long ago. So what I'm showing you here is independent of and fundamentally different from a Gilbreth routine or consequence. Okay, so the Gilbreth principle is not being in any way applied here because it doesn't apply. We don't have a cyclic packet at any point. Okay, so, well, thank you for watching, and take a look at other videos on the Absolute Math Magic channel.